Okay, let's review 6.1 through 6.4. And 6.1 through 6.4 focused on equivalent fractions, simplifying fractions, and common denominators. So the first thing we're going to take a look at is equivalent fractions and how to create equivalent fractions, and then how to determine if two fractions are equivalent or not. In order for us to even start, we have to take a look at some basic vocabulary. We have to figure out what these different parts of our fractions are called, and then what equivalent means. So let's do that first. Our top number in a fraction is called our numerator. And the bottom number in our fraction is called our denominator. Now, equivalent means equal. So when we're creating equivalent fractions, we need to create a fraction that is equal to the one that we're given. If we started with 2/3, we can draw a diagram to figure out what 2/3 represents. I'm going to draw a rectangle, and I'm going to split my rectangle into 3 even pieces. Now, 2/3 would represent, or could represent, if I had 2 out of 3 of these pieces shaded in. In order for me to create an equivalent fraction, I need to make a fraction that has maybe more sets or maybe less parts, but that also has the same amount of the shape shaded in. So, if I took this same rectangle, and instead of just having it split into 3 parts, I'm going to now split it into 6 parts. How many pieces are shaded? Because fractions represent parts of a whole. Well, now I have 6 total parts, and 4 of those parts are shaded in. All I did was draw a line through my shape to make another 3 equal parts in that same shape. So I have 2/3 and 4/6, and these fractions are equivalent. Now, we're not always going to be able to draw shapes to represent equivalent fractions. We could try, but it could get difficult at times. So let's take a look at how we create equivalent fractions another way. Let's take the fraction 4/5, and I want to create an equivalent fraction to 4/5. I want to make a fraction that's equal to 4/5. Now, if we take a look back at our fraction that we just did, we need to see how we went from 3 to 6 and 2 to 4. And we'll notice that when we go from 3 to 6, we multiply times 2. And we do the same thing to the numerator. And that's really important. We need to do the same thing to the numerator and the denominator. Whether it's multiplication or division, it needs to be the same. So, if I take a look at my fraction 4/5, I want to create a fraction that's equivalent. So I'm either going to multiply my numerator and my denominator by the same number, or I'm going to divide. Now, I can't divide 4 and 5 by anything. They don't have any factors in common other than 1. And if I divided by 1, I'd get 4/5 again, and that's not going to help me create a new fraction. So I'm going to multiply. And you could choose any number that you want to multiply. It's generally a lot easier if you just choose 2 and 3 and 4 and some of those smaller numbers, but if you want to choose larger numbers, you may. The most important thing is that we do the same thing to our numerator and our denominator. So I'm going to multiply my numerator and my denominator times 2. 5 times 2 equals 10, and 4 times 2 equals 8. Now I have a new fraction. 4/5 is equivalent to 8/10. I could take that same fraction, 4/5, and multiply my numerator and denominator by something else. Maybe I want to multiply each times 5. And I'm going to create a different equivalent fraction. 4 times 5 is 20, and 5 times 5 is 25. If I lined all these fractions up, 4/5, 8/10, and 20/25, they are all equivalent to each other. You'll notice that their denominators are all multiples of my simplest form of the fraction, 5. 5, 10, 25 are all multiples of 5. You'll also notice that we did the same thing to our numerator and our denominator to create that equivalent fraction. Now, we're also going to need to compare fractions to identify if they are equivalent, so if they're equal, or if they are not equivalent or not equal. The steps that we have to take in order to figure out if two fractions are equivalent or not are similar to the steps that we took to create our equivalent fractions. We're going to start with 1/4, and we are going to see if we can do the same thing to my numerator and my denominator in order to get 2/8. So, if I look at my numerator, in order for me to go from 1 to 2, I have to multiply times 2. Let's see if I can do the same thing on the bottom and get 8. If I multiply my denominator 4 times 2, do I get 8? Yes, I do. Because I was able to multiply my numerator and my denominator by the same number and get those individual products, then these two fractions are equivalent. Now let's try and do the same thing over here. I have 3/5 and 6/9. When I go from 3 to 6, I multiply times 2. If I'm finding equivalent fractions, I have to do the same thing to my numerator and my denominator. So I'm going to multiply my denominator times 2. 3 times 2 does equal 6. 5 times 2, though, that equals 10, not 9. These two fractions are not equivalent. Now there's one more way that I can determine if fractions are equivalent or not. Now I like to call this little trick the butterfly technique. And this is going to allow us to not only find out if our two fractions are equivalent or not, but it's also going to let us know which fraction is greater, which is going to come in handy later on in this chapter when we're comparing fractions to figure out which one's greater. So what we're going to do is we're going to create our butterfly wings. There's one wing. There's another wing. Now butterflies have antennae that come up. Okay. Now what I'm going to do is I'm going to multiply that circle that I just created. So here I'm going to multiply 3 times 10. And over here I'm going to multiply 4 times 6. 3 times 10 is equal to 30. That's the product that I get. And 4 times 6 is equal to 24. Now, did I get the same products? Are 30 and 24 the same? Are they equal? No, they are not. So these two fractions are not equivalent. What this also tells me is because this product over here is greater than 24, then 3/4 is greater than 6/10. Let's try one more just like that. Again, I'm going to create my butterfly wings. And then I'm going to make my antenna. Okay. 5 times 12 is 60. 6 times 10 is 60. I have two different products that I just got, 60 and 60. Those products are the same, which means my fractions are equivalent. So that's another little handy trick when we're trying to figure out if two fractions are equivalent or not. We can use this method where we have to see if we're multiplying the same number on top and the bottom. If not, then they are not equivalent. We can also use our butterfly method. Okay. Now our next step is to simplify our fractions. And simplifying our fractions means we need to make our numerator and our denominator smaller. But in order to do that, we have to find common factors of those numbers, and then we're going to divide by that common factor. Now, the easiest step to look at, or the easiest thing to look at, is if our numbers are even. If our numbers are even, we know they're always going to be divisible by 2. So, let's take a look at our numbers. We have 8 and 12. Both 8 and 12 are even. So, both 8 and 12 are divisible by the number 2. So I'm going to divide both 8 and 12 by 2. And I'm going to get an equivalent fraction with numbers that are smaller than 8 and 12. 8 divided by 2 is 4, and 12 divided by 2 is 6. Now I'm not done yet. I have to take a look at the new equivalent fraction that I got, and I have to see if this one is in its simplest form. Well, are both of my numbers even? Yes, they are. And so they're both divisible by 2 again. So I need to divide again by 2. When I do that, 4 divided by 2 equals 2, and 6 divided by 2 gives me 3. Now, how do you know if your fractions are in the simplest form? Sometimes it's tricky to tell. Our fractions are always going to be in the simplest form if they have a 1 in the numerator. So a fraction like 1/4 or 1/10, those two fractions are in the simplest form. They have a 1 in the numerator. Our fractions are also in their simplest form if both the numerator and the denominator are prime numbers. So, for example, if I had 3/5, 3 and 5 are both prime numbers. If I had 7/11, both of those are prime numbers. So both of those fractions would be in the simplest form. Our fraction is also in its simplest form if the numerator and the denominator are sequential numbers. That means if I have something like 2/3, where 2 comes right before 3. Or if I have 4/5, or 6/7, or 9/10. All of these fractions are in the simplest form. Notice how their numerator is 1 less than their denominator. Now, we do have a red flag. Here is where I see students make the biggest mistake. So here's our red flag. If both numbers are even, so if we have 4/6, or we have 8/10, or we have 2/4, none of these are in their simplest form because all of these are divisible by 2. All even numbers are divisible by 2. Let's take a look at some fractions and let's simplify them using some of those rules. Okay, we have 9/12. Our first step is to look to see if both of our numbers are even. Are 9 and 12 even numbers? Well, 12 is an even number, but 9 is not. So that answer would be no. So they're not both divisible by 2. But that does not mean that 9/12 is in its simplest form. We have to think if 9 and 12 have another common factor. If you don't remember, then we can find the factors for 9 and 12. 9 and 12. 9's factors are 1 and 9 and 3 and 3. 12's factors are 1, 12, 2 and 6, 3 and 4. Do you see any numbers that 9 and 12 have in common? The number 3. Which means I can divide 9 and 12 by 3. Remember, just like when we did our equivalent fractions, when we're simplifying fractions, whatever we do to the numerator, we have to do to the denominator. So I'm going to divide by 3. And when I do that, I get 3/4. Now, I can go over my checklist, the list that I made before. Does the fraction 3/4 have a 1 in the numerator? No, it does not. Are both of the numbers prime numbers? Well, 3 is prime, but 4 is not a prime number. Are the numerator and the denominator sequential numbers? That means does one come after the other? Yes, they are. They are sequential numbers, so this is the simplest form. Once you go through those 3 steps, that does not mean that you're in the simplest form. You need to then see, is our number divisible, are our numbers divisible by anything else? So go through your divisibility rules and check to see if your numbers are divisible by anything else. Okay, now, whenever we have a fraction with the same number in the numerator and the denominator, it's always going to be equal to 1 whole. This basically means you have a pizza, and your pizza's cut into 8 slices, and you eat all 8 slices of your pizza. You eat that one, and that one, and that one, and that one. You eat all of these slices. How much of your pizza have you eaten? Well, you've eaten the whole thing. Any fraction with the same number in the numerator and the denominator is equal to 1 whole. And it simplifies to 1 whole. Okay. Now, we've talked about simplifying fractions, and we've talked about finding fractions that are equivalent to one another. Now we're going to talk about finding fractions, or creating fractions rather, with common denominators. Now, if I took a look at 1/2 and 2/3, and I said, my friends want to take some baseball cards, and they want one person to get 1/2 of the baseball cards, and the other person's going to get 2/3 of the baseball cards that they have. It would be equal to more than a whole, but that's besides the point. We could not split things up so that they would get the amounts that they're supposed to get right now, because our denominators represents the whole. And I have 2 different wholes that I'm looking at right here. I'm looking at 2 in a whole and 3 parts of a whole. And I can't have 2 parts of a whole and 3 parts of a whole and split that up. So what I need to do is find a common denominator. And in order to find a common denominator, I need to find common multiples between my numbers in my denominator. So I'm going to list my multiples for both of my denominators. I'm going to list my multiples for 2, and I'm going to list my multiples for 3. 2, 4, 6, 8, 10, 3, 6, 9, 12, 15. Then I'm going to circle what they have in common. I see that they have 6 in common. So this is my first step right here. Step number 1 is to list our multiples of my denominator. Step number 2 is going to be to rewrite my fractions. I'm going to take 1/2, and the new denominator that I want it to have is the number 6, because that's what the number 2 and 3 have in common. Then I'm going to take my 2/3 and I'm going to do the same thing. I'm going to make an equivalent fraction with 6 in my denominator. Now, remembering back how I found my equivalent fractions, whatever I do to my denominator, I have to do to my numerator of that specific fraction. So, when I go from 2 to 6, I multiply times 3. That means in this fraction, I need to multiply my numerator times 3. 1 times 3 is 3. And here is one of my fractions that has a 6 in my denominator. Now, I need to go to my other fraction, and I have to look at that specific case. I'm not going to necessarily multiply it times 3. I'm probably not. I have to figure out what I need to multiply my numerator and my denominator by. So, when I go from 3 to 6, I multiply times 2. I'm going to do the same thing to my numerator, and I get 4. When I look at these 2 fractions that I put boxes around, you'll notice that I have the same number on the bottom. I have a common denominator, the same denominator. Their numerators are not the same, and that's okay. These 2 fractions are not equivalent fractions. 1/2 is not equivalent to 2/3, but I needed to find what they had in common first for their multiples, and then I created 2 separate fractions with that number in my denominator. Let's take a look at the last one. We have 3/5 and 2/4. Again, I'm going to do the same thing. I'm going to list my multiples first of my numbers in my denominator. I have 4 and I have a 5. So I'm going to list my multiples of 5 and of 4. 5, 10, 15, 20, 25, 4, 8, 12, 16, 20, 24. You don't have to go on forever, but you should list about 5, 6, 7, or at least until you find something that they have in common. I see that I have the number 20 in common with my multiples. And again, this was my first step. Step number 1 is to list my multiples. Step number 2, I'm going to rewrite my fractions. I'm going to take 3/5, and I want it to equal something over 20. And I'm going to take 2/4, and I want that to equal something over 20. Now I need to figure out what those two numerators are going to be. When I go from 5 to 20, I multiply times 4. So I need to do the same thing in the numerator, and I get 12/20. When I go from 4 to 20, I multiply times 5. So I need to do the same thing in my numerator, and I get 10/20. And that's it. I now have two fractions, a pair of fractions, with a common denominator. So let's review real quick what we talked about. We talked about making our equivalent fractions, and I'm just going to write EF for equivalent fractions. And when we do that, we take a fraction like 2/5, and we're going to do the same thing to our numerator and our denominator. We'd multiply times 2, let's say, and I'd get 4/10. So 2/5 is equivalent to 4/10 because I did the same thing to my numerator and my denominator. We also talked about simplifying fractions. So I'm going to put SF for simplifying fractions. And when I do that, I have to divide my numerator and my denominator by the same number. If I had 6/8, both of these numbers are even, so I'm going to divide by 2. And I would get 3/4. Now, because what I got right here, this fraction, my 3 and my 4 are sequential, I know that this is the simplest form. If I would have ended up with something different, I would have gone through those steps and seen if they fit any of those steps. If not, I'd have to find the factors and find something that they have in common other than 1. The last thing that we did was we found common denominators of fractions, so C and D. And when I find my common denominators of two different fractions, let's say I had the fractions 2/6 and 3/4. I would first find my multiples of 6 and 4. 6, 12, 18, 24, 4, 8, 12, 16, 20, 24. I would circle what they have in common, and then I would rewrite my fractions to have that new number in the denominator. I have to rewrite both of my fractions, not just one of them. I have to create that equivalent fraction, so again I'm doing the same thing to my numerator and my denominator. And there we go. We have two fractions with common denominators. Okay, that is all. 6.1 through 6.4. Equivalent fractions, simplifying fractions, and finding common denominators.